Good morning all. In today's class, I am going to discuss about corona. I am pretty sure that you all are familiar with the term coronavirus and COVID pandemic. And you may be wondering why I am telling this corona in an electrical engineering class. So that's what I am going to discuss today. So let me take the presentation. So corona, it's a phenomenon happening in high voltage transmission lines. As you can see, it's an effect occurs in high voltage transmission line. So high voltage transmission line consists of several conductors and they are placed in air. Now we know air is an insulator, but it's not a perfect insulator. It consists of molecules, gaseous molecules, random ions, etc. So there's one more condition to occur corona. The spacing between the conductors must be large compared to the diameter of the conductor. Now if the upright voltage is low, there won't be any change in atmospheric conditions surrounding the wires. Now if the upright voltage is higher than critical disruptive voltage, something interesting will happen. The conductors are surrounded by a faint violet glow called corona. Now the value of disruptive voltage of air is 30 kilovolt per centimeter. So this air consists of ions, and if the voltage across the conductors is beyond the critical disruptive voltage, more ionization will happening around the conductors and the air becomes somewhat conducting in nature. So you can see in this animation, we have this conductor and the air consists of ions shown as red bubbles. When the voltage increases, more ionization will happen and more amount of ions will be produced. And due to the presence of these ions, some discharges will happen near the conductors and which can be seen as a violet glow. So we can see some violet glows at some parts only. Why? Because we know the conductors is not smooth throughout the entire line. At some point, some dust particles will be deposited. At some points, there may be some irregularities due to manufacturing process. So at those points, this visual effect can be seen more. So this phenomenon is called corona. So corona is associated with a violet glow, hissing sound, ozone production, and also some negative effects also power loss, radio interference and insulation degradation. So if voltage upright is more, we can see more glow and more noise. Now factors affecting corona are the first one, atmospheric conditions. We know the directive strength of air is higher, is directly proportional to the density between the conductors. So in a clear weather, the corona effect will be less because the number of ions present is less. And in a stormy day, its effect will be more due to more number of ions present. Now the conductor nature, the size and shape of the conductor. If the diameter of the conductor increases, the distance between the conductor reduces and corona effect will be less. Now the shape of the conductor. The conductor can be smooth as shown the upper one. It can be stranded as shown the lower conductor. In the upper conductor, the surface is smooth. In that case, the corona effect will be less. In the lower conductor, some irregularities are there due to the presence of strands. So in this case, in a stranded conductor, the corona effect will be more. Now, if the surface is clean, its effect is more. If it is dirty, dust particles are deposited at some points. More amount of dust particles are present at some points. At those points, this effect will be more. And if the spacing is higher, corona effect will be less because it requires more amount of voltage to break down the air. If the line voltage increases, corona effect will be more. So critical disruptive voltage is the minimum voltage at which corona occurs, but the minimum voltage at which corona glow appears is called a visual critical voltage. There are some methods to reduce corona by increasing size, bundled conductor using, improving surface finish and use of corona rings. So here you can see the corona rings to reduce the effect of corona. So to conclude, it's an effect occurring in high voltage transmission system. It leads to some negative effects called energy loss, noise and equipment degradation. So the engineers must develop effective strategies to mitigate its effects. Thank you.